Hopefully I'm back now. Let's see. Let's give it a minute. Any luck? Maybe. I can see myself drinking coffee now. Okay, and I don't think I lost it. That's a good sign. Any luck? Let's drink some more coffee. Give it just a minute here. Let me know if it's back for you guys. Okay, cool. So, what's cool behind the scenes here is how this stuff works with strings versus numbers. So, we talked a little bit about memory last chapter. Remember that everything gets stored in computer in binary, those bits and bytes, and 8 bits make up a byte, and it's all ones and zeros. And everything in memory gets these like memory addresses. We typically label them with an X because it's in hexadecimal. I don't remember why, but that's okay. So like 7426F might be a memory address. That's probably a bad one, but that's okay. It should be a 64-bit memory address, but sure. Just pretend this is okay. So what we normally get, say if I wanted like my magic number, this is my magic number, and it is stored at this location in memory. And when I ask Java to go get a value or go change the value or set the value, it goes and asks the operating system, hey, what is stored over there? And I might put in 42. So the integer value is stored at that location in memory. So magic number is using this memory address to get a value directly. Excuse me. So we're able to put values there. Now, the reason that this works is because we tell the computer, hey, remember an integer is 4 bytes. So everything in memory from 7426F plus the next byte of 74270 and 74271 and 74272, right? Those 4 bytes all hold up the values, of 00000000. It's a bunch of zeros here because 42 is not a very big number. 0000000, and then 42 would be a 2 is on, and then 40 is 32 plus 8. So it's 2, 4, 8, 16, 32. There we go. Okay, that looks about right. So all of this nonsense here is stored starting at this memory address, 7426F, 4 bytes in a row. So when I go ask Java to go get the value, it tells the operating system, hey, go read what's there, read these 4 bytes, because that's the size of an integer. And we can change things, and we can do our arithmetic and whatever. We can change the values that are stored here. Is that straightforward enough? Again, we don't need to know too many of the fine level details. This is more an interesting fact of how it works. But when we talk about strings, it's going to be different. So, and remember, binary is base 2, so this is like the 1s, this is the 2s, this is the 4s, the 8s, the 16s, the 32s, the 64s, the 128s, and on and on and on. That's how I knew it was 00101010 for 42. Don't memorize that. So we can store as an int, right? That's an integer, this location. Does that make sense? So we'll say, hey, give me 4 bytes, because I know I can fit an integer into 4 bytes. Usually I'd look around for some people doing their head nodding, which is unfortunate. You don't have that, but it's okay. So there's a whole debate in education here about Zoom University and Zoom classrooms and things, and some schools have taken some approaches and other schools have not. So the public school in the area here in K-12, the high school remote learners are being told they must have their webcams on, and teachers can even score that for participation if they are showing, including head and shoulders, was the official memo we got from the principal. That just makes me a little sad, but that's okay. And the advice we got from our new provost here was, well, let's try and respect people's privacy, because not everyone might want to turn on their camera and have a good place to hang out and whatnot, and trying to grade that really has nothing to do with your actual work is kind of rough. I get like discussions and participation and being able to engage in classroom activities. I get all that, but thankfully we're not a discussion-based class. And those are a lot of fun. I actually have good fond memories of my philosophy class, or was it Intro to Logic, I think I had to take a while back, which was really good. Those are good classes, and discussion definitely important there, but thankfully we don't have that. But sometimes I do miss seeing you guys and seeing everybody head nod. So that's okay. And we did get the word from our provost that I just mentioned that the summer semester will be mostly remote, similar to what's happening now. They're looking at, thank you, Dusty. They're looking at some things, but given that it's starting in May and the vaccine rollout is still relatively slow, and that most of your faculty members are in the more higher risk populations, not the over 65 for most of us, but summer will be mostly remote. So we did get that word. But come fall, they're hoping, fingers crossed, we can get back to normal. So we'll see how it goes. We'll see. I'm hoping I can still dual teach in the classroom, see people, and broadcast myself on Twitch, because you can see me on the laptop, and that's what I used to do before all this pandemic stuff happened. So I'm looking forward to that. Okay, so we got one nod out of a couple people who are hanging out. That's okay. So that's what we can do with an integer value, right? Now, let's say, hey, Java, I want some memory to store a string. So, okay, sure, let's x2344. You can put a string here. String. But a string could be Eric, 4 letters. It could be a single character. It could be number values in a string. It could be an entire sentence. It could be a paragraph. It could be the entire book of Moby Dick, right? In a single string, I could store all of Moby Dick. How does Java know what to go store? Like, how does it go ask for, give me some bytes? How many bytes should it ask for? Here's the funny thing, is a string variable actually stores another memory address, x3724b. Sure. Why not? Call that another memory address. I try and put letters in there so that it's not just numeric, it's hex. So every string stores a memory address, and this memory address then can have the actual whatever you wanted to store as a string in whatever particular size. And somewhere in here it tells Java how big it is. I forget exactly how that works, and that fine level detail is probably not all that important here for our purposes. But the idea is that a string references another location in memory. So we call it string, it's a reference variable. There's a difference here. So it references the string, and we call them objects. It's the location of an object. So in Java, we have primitive types, which are our ints, our doubles, our floats, our bytes, our chars, all those other particular, the small letter ones are the primitives. And there's the whole list of different values we could use. Again, I'm partial to ints and doubles because they make life easy. The other types are great and they're useful if we want to do some optimizations. This is 1500. We're not going to optimize anything. Don't worry about it. You can worry about that later. Okay, we just want to learn how to code to start. So what a string does is it's referencing an object. So it makes a new thing in memory and it can size it as whatever size it needs to be. So a string value is stored somewhere. What's stored there is another memory address. That memory address then points to the string. So it's like, imagine doing two hops. You tell Java, hey, give me that value of the string. And it says, oh, okay, let me go get the value. Oh, it's a memory address. Let me go read that next memory address. So it has to hop, boop, boop, to get to a location. The benefit of that is it knows every string is 64 bytes? Not bytes. Let's see. Java address size. Let's see. Let's Google that. Let's see what size it is. This might work. Memory address variables. Is that what I want? This might be what we want. Aha. It's a hash, memory object. Yes. Okay, 64 bits. Yeah. Okay, 64 bits would be 8 bytes. Yep, okay. That's what I was looking for. So most systems nowadays are 64-bit systems. So most of our addresses will be 64 bits or 8 bytes. So a single integer was only 4 bytes, right? So we could store 2 integers in the size that it takes us just to store where that string is in memory. And that's okay. I mean, memory is relatively cheap in computers. You know, obviously we can optimize things here and there, but so don't worry too much about that. So this was sort of a weird offshoot, but the idea is when I create a string, what class name is storing is where this thing is in memory. And strings are what we'll call immutable, is that you can't change them. And the reason why is because when we ask for a certain chunk of memory, we're not asking for more. So if I wanted to take CIS 1500 and then maybe I wanted to say class name equals class name plus intro to programming, and then we'll add on here, right? So we'll have the name, the code, and then we'll add in the title here. What it does is it makes another string in memory sized this big to fit all of those characters. And then it changes class name. So it says, okay, class name, you no longer point to 37247B, you point to, how about 3941A, which is over here with the new string. So the location here doesn't change, but what it's storing changes from this one to this one because we put a new string in memory. So every time you modify a string or do this appending of a string, it has to go put it in a new location because it's a reference type here, and strings are immutable. So I'm referencing the string object. Kind of a crazy offshoot. I'm sorry. It's worthwhile to know and just keep that in your back pocket. It's not going to impact too many things that we do right now, but some cool things that we can do with that once we know that string is an object is we can do things like class name, and if you put a dot after, so my variable name dot something, I can get some interesting stuff. Now, some of these we'll get to, and they'll be much more interesting next chapter. But we could say, hey, what's the length? Like, how many characters are in this string? And notice we get, if you click on each of these, you should get this help text, which is really nice. This comes from the Java API, all of its help documentation. So length says, returns the length of the string. Length is equal to the number of Unicode units in the string. So how many characters are in the string? Right? I could replace, which will give me a string that is replacing all the old characters with the new characters. This one's fun, and you do it character, or you can do it by string. So this will replace one character at a time, or you can also replace strings at a time. So this was kind of fun. We did class name. Let's see, we had name in here, right? I've got name. My kids had the most fun with this for some reason. It's name, username. Yeah, I think it was username. So let's print out username, and then I'm just going to add in here username. Right, we can do this concatenation. Take a string, stick another string on the end of it, and then we can replace all the vowels with oob. So it was a funny thing that someone posted online. It's like, take your name and replace every vowel in your name with oob. So I was oobra ook. Sure, I mean, why not? So we're going to say username, and we're going to assign it. We're going to change the value of it, is username.replace. And we want to replace, let's see, we wanted to replace the old, so I'm going to replace a E with the new with oob. That should be a string there, right? I think I can do it that way, right? Oh dear. Semicolon. Okay. Now, I have to do this a couple times, right? Because I have to do it for every vowel. So A, E, I, O, and U. A, E, I, O, and U. Okay. And then I can print out my username again. So each time it's making a new string, because remember, you can't change a string. It's immutable, but it can make a new string, and it says, okay, now you equal this thing. If I replace all the O's with oob, I'm going to get a lot of other ones here. So let me do that one. I can't even do that one last, can I? I don't think I can replace O's, because that's going to cause some trouble. That's all right, my name doesn't have an O in it. We'll forget that one. Otherwise, we'd run into some trouble here. Let's try this. Let's see what we get. So enter your name, Eric Charneski. And again, it is case sensitive, so I'm going to do all lowercase because I know I did lowercase letters over here. Guess a number, enter another number. There we go. Ubra ook Chubranubski. There we go. That's Eric Charneski, where we've oobed all the vowels. That was totally worth it, right? I guess if we did O first, right? If we replaced O first, we could do this, yeah. You replace the O's with oob, then we can replace the other ones, and we're not going to find any of these oobs to go replace again. Let's try it. Let's see if I can throw an O in there. Let's try it. Let's try it. This is fun, right? So let's do Oscar the Grouch. He's my son's favorite character in Sesame Street, or one of his favorite. He likes most of them. Oobska Oobra, the Doob, Groob, Oob, Ksh, Grouch. Yeah, I think that worked. You guys are entertained, right? This is quality content. Oob, oob, oob. All right, cool. I got all the stuff finally printed. My wife needs the papers. I think we're in good shape here. All right. Okay. Oh, my sugar's going up. That's right. How you guys doing so far? This is a little bit weird for content. But we can do fun things with strings. Right? Strings have a lot of fun options. Nods. Okay. Thank you, Dusty. I got one nod. It says there's 16 people hanging out, but I don't know if I believe that or not right now. Maybe everyone's just quiet. Joob noob noob boob doob doob boob boobin doo boob doo boo. I don't know what your name is there, but sure. All right. We're just having some fun with strings. Yes, a head nod emote. Awesome. I should do that. There's like an okay emote or something like that, right? Like thumbs up. I think there's a thumbs up or like a seems good or something. What is there? Thumbs. Yeah. Oh, maybe not. Maybe you have to let's see. Yeah, what's that one? Seems good. There we go. Seems good. I like that. Yeah, I've got some thumbs up emotes, but they're from other channels that I subscribe to, so you guys probably don't have those. Yeah, we could do a head nod, or we could do something else. I should add some like channel points for head nodding, right? You can redeem a couple channel points and head nod. Redeem a couple channel points and shake your head no. Sure, we could manage something like that. Okay. Other cool things we could do with strings, right? Username. We're going to change it here. Username dot to lowercase. We'll take all of the characters and make them lowercase. Boom. So if I want to not have to worry about replacing uppercase O's and lowercase O's and uppercase A's and lowercase A's, I can just make it all lowercase right now. Right? And then I could change it again. Username dot, where is it here? Username dot, is there some casing option here, right? So we could put it back to, uppercase would put everything uppercase. I thought we had a title case option, but maybe not. Maybe not here in Java. That's okay. I'll look it up. Thought it was there. Java Spring title case. Perhaps not. Ah, we have to split. And then we have to do things. That sounds messy. Sure. Oh, look, here's a code example. Excuse me. That looks like something we would write. No. Okay. So probably not so good right now. That's okay. We can come back to title casing another time. We can save that for another day. But we can lowercase it. Okay. Got it. All right, let's see. What else are we missing here? Trying to make sure I get all the important stuff. Comments, Java doc. You guys can look up Java doc. It's not hard. For style and the way to organize things, I'm a big fan of just letting NetBeans do its thing, because then I don't have to do any work. So you could do Shift Alt F, and it will format stuff for you. So if you have things that are, at different lines, and some of these are over at different places, and some of these are over here, don't fix it by hand, right? Let the tool do the work for you. We have a tool for a reason. Shift Alt F, format, right? Or under source, I think it's in here somewhere. Shift Alt F. Yeah, oh, format. There's the first option right there. So if you don't like the keyboard shortcuts, you can just come up to source and hit format, and it will format it for you according to its style. And you can change these style preferences. They're NetBeans options if you want, and different places have different styles. I'm just fond of when everyone has the exact same style, because that makes life so much easier, right? And notice it converts tabs to spaces, which makes me sad, but that's okay. I can live with it, and I don't have to do any extra work. So if I want to tab something in, right, I can tab it in, but then it just turns it into spaces. So tab and I get spaces, but that's okay. Right, we'll just let the tool do its thing and format. It will make itself happy, which is awesome. So that's some style guidelines. I'm not going to give you points for style, because the tool can do that for you. And why should I give you a point for hitting the format button? That seems silly. Scanner, you might have noticed. Here, where do we use scanner? We started it up here. Scanner is not a primitive type. Remember, these primitives are all these like lowercase, like doubles and ints and floats. Those are primitive types where we're actually storing the value. Chars and booleans, doubles, those are primitives. So scanner is a object. So scanner is a class that's written, and we make an instance of that class so we have an object. Those are all technical terms. So the idea is when you're using the class, in this case we're using an instance of it, and this instance of scanner knows how to read from system.in, our standard keyboard input. You can do other cool things with scanner we'll tackle later. We use it for doing file input and output another time. Okay, but so scanner then is a reference type. My variable here, keyboard, is referencing some location out in memory wherever this scanner thing got loaded up and stores information that its scanner needs. I don't know where it puts it. It's not important to me. We just know that, hey, it's referencing this thing over here. So that's a reference type. So strings, because they're so common, you can use this syntax and Java's happy with it. The other thing you could do, say string, this is the hard way. You could say equals a new string and give it something. Why do this? This is proper, perfectly legal Java code. It's the exact same thing as what's happening up here. Java just says, oh, you're giving me a string, you probably wanted a new string. But anytime you see this new keyword, you can be sure we're doing reference types. Because we're telling Java, hey, I want a new thing in memory. Go get a place for me to store this. I'm going to reference it. So new is kind of the keyword there for reference types. So we can with strings, but you'll never see anybody sane doing this because there's no reason, right? Java does it for you. And why would we do more work than we need to? But this is legal. Right? There's nothing wrong with this. It's just silly. Mr. Gaddis likes the J option pane, but that's okay. Yep. Cool. Integer and doubles and parsing. Cool. All right, I think we made it through all the Chapter 2 content. You guys did good. We can spend some more time practicing. We can talk about Project 1. What do you guys think? I'm open to suggestions here. Talk about Project 1. I like it. Project 1. So I'm going to go to assignments, go find Project 1. And I will edit Project 1. Make sure I did this right too. Desire to Learn has some defaults because they assume everyone's going to use it to upload stuff. And when you don't ask people to upload, it wants a file. Of course, I should change that. You just need to give me the URL. So please submit the URL to your Java file or GitHub repository. There, I don't want a file. I just want the URL to your Java file. Okay, perfect. Sometimes I forget to change that, and then people get confused about why they have to upload a file, and I have to tell them it's because I'm dumb. But everyone gets a good laugh out of it, so maybe it's for the best. Yep, same as Project Zero. So you're going to give me the URL to your file in github.com. Yep. So, and I've got half of those Project Zero scored. I'll get back to getting the rest of them done here later today. We should be in good shape. So we're just writing a little program to help out our contractor friend figure out how much lumber to buy to build a fence. So these asks thems means we need to print out a message that says, please enter this value. So get their name. And then we're going to use their name in all further prompts. So when they tell me what their name is, I can print out their name along with the question. Like, hey Bob, how far apart are your posts? Hey Bob, what's the length and width of your fence? And you probably need to ask them separately, like what's the length and then what's the width? Because it's hard to store two different values here in a single answer, right? And then, hey, what length boards are you going to purchase? So if we are trying to build a fence here, right? And I say, hey, I've got posts every 4 feet for posts here, right? For my posts, 4 feet apart, right? And I let's say I could buy an 8-foot board. So if I have a board that's 8 feet, how many sections between the posts can I turn this board into? Well, I have to do some arithmetic, and I'll find out, hey, I can cut that into 2 4-foot sections. Great. So for whatever the length is, right, and then whatever the width is, right, assume it's a nice rectangle, figure out how many boards we're going to need, right? Well, that's 1 board, that's 2 boards, 3 boards, 4 boards, 5, 6, 7, 8, 9 boards. Don't do it like that, right? Do the arithmetic. I'm just showing you here, right? So we can figure out how many boards we're going to need to buy, how many we'll have left over. Say I could buy 10-foot boards. If my posts are 4 feet apart, well, I can cut, here's a 4-foot section, here's a 4-foot section. This 2-foot section over here is just scrap. Yeah, just, it's a crappy fence. So just a single board goes between each post here. It's not like one of those really pretty ones you got like 3 different planks or anything going on like that. But if it was, like we could ask them, hey, how many planks do you want between, or how many boards do you want between each post? And we would just multiply our answer. So any scrap we're just getting rid of is just going to get thrown away. We could, for a bonus point, calculate the amount of board it was wasted. So see, okay, well, if I had to buy 9 10-foot boards and each of them I lost 2 feet of, I had to throw away 18 feet of board. You're asking for the distance between the posts. So I might say, oh, I've got a post over here, and 6 feet later I'll have another post. Sure, why not? Or maybe I have a post every 2 feet. Right? Sure. Maybe I have a post every 10 feet. I don't really care. We're going to assume your contractor friend is not dumb and is not going to say, hey, I have posts 10 feet apart and I'm buying 8-foot boards. Okay? That will do bad things in our program. So we don't know how to handle that right now. So don't worry about it. We'll just pretend it doesn't happen. Pretend our contractor friend is smart. And actually, there's a lot of math contractors have to do. So they're definitely no dummies, for sure. Yeah, so we're saying how far apart are the posts and what the length of the board is. So if I had posts every 4 feet, I bought an 8-foot board, I could get 2 boards out of every, 2 cuts out of every board. If I bought a 12-foot 2x4 or something, right? And then my post's worth, 5 feet apart. Sure, how many 5-foot lengths can I get out of this length of board? So depending on the values, right? It's 1, it's 2, it's 3, it's 4. If you have posts every 1 foot and I buy a 12-foot board, well, sure, I can do 12 posts worth here with a single board. I mean, whatever numbers we want to use, we should be able to do the arithmetic with. So the number of boards that they have to buy, right? That's, make sure you're using the perimeter of the fence, not just length and width one time. And if you want a bonus point, tell me how much board was wasted. So you're going to be well served. Let me see if I can go down a line here. If you don't just start writing Java code right away. Remember this idea of writing software, it's an art and a science, and the art is designing it, right? Like what's step 1? What's step 2? What's step 3? So this idea of getting things down in like an English version, we'll call pseudo code, and this is really popular, and it's a great way to design programs and just kind of to work through your ideas here. So we can say, okay, well, I need to get a value here. So, ask for length or something, right? And then ask, those are terrible, I'm sorry, for width, right? And then we calculate perimeter or something, and perimeter is length times 2 plus width times 2 here. But the problem is it's not just a perimeter, right? Because we can't just say, hey, here's the entire perimeter, because if I have posts, where I would run into trouble, right? So if I had posts here, 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 and here, and here, so let's say this was a 15-foot length, and I had posts every 3 feet. So here's 3, 6, 9, 12, right? 3, 6, 9, 12. One more for 15. 15 feet, right? So that's 1 post, 2 posts, 3 posts, 4 posts, 5 posts. So it's 6 posts to get 15 feet. Right? So make sure that we're calculating here the distance for each board, however much I can put in here. Or if I had 12 feet apart here. Right? So to calculate how much board I would need for this one, if this was 3 feet, and this was 3 feet, and this was 3 feet, and this was 3 feet. No, my 15 was better, I'm sorry. Yeah, 15 is going to work better. So if I were to buy 6-foot boards here, let me draw this out better. So here's the first post, right? That's at 0 feet. Here's the next post at 3 feet. Here's the next post at 6 feet, 9 feet. That's what's going on. Was I missing a number? I think I was just missing a number. 12 feet. Yeah, I was missing a number. I can't do math. So if we have a 12-foot fence here, and my posts are every 3 feet apart, and I buy, say, an 8-foot board, right? Well, I can cut an 8-foot board into a 3-foot section, a 3-foot section, and a 2-foot section. Sure. So one board can go here and here, and then I get another board, another 8-foot board, 3, 3, and 2. I can put one here and one here. Right? So I've filled up those sections. That one worked. Right? So I need 2 boards to get 12 feet of length of fence. But if I had a 15-foot fence here, 6, 9, 12, 15-foot fence, 15 feet, right? So I need a 3-foot section, a 3-foot section, a 3-foot section, a 3-foot section, and a 3-foot section. That's 3 boards if they're 8 feet each. But then I have one left over. Right? So just be careful that we're not calculating it but at a single length and saying, hey, you need 3 boards, and then multiplying that by 2. 3 boards times 2. Right? You need to get the total distance and figure out how many sections you're going to need. So make sure we're doing it off of perimeter. Parameter. You can't see that bottom corner, can you? So just with your calculations, just be careful, right? So how many pieces of board are you going to need to connect those posts? Does that make sense? Hopefully I didn't make that worse. I feel like I might have made it worse. But again, it's all arithmetic, right? We're not actually, I'm kind of like showing how we might do this by hand, but there's the arithmetic we can do if we know what a perimeter is and by dividing it. We can do some sort of nice logic there and figure out, okay, based on the length of my board, how many good sections do I get and how many are going to go to waste. And if I know what the waste is, I can multiply that by how many boards I buy, and I've got my bonus point. My handwriting is pretty much just as bad on a real whiteboard, just FYI. How are we feeling? What else can we talk about? You okay getting integer values with scanner? Remember, to get the integer values, we need to get their input here, and I will recommend you use next line and then convert it, integer.parseInt. So this is my preferred way. The scanner can do things like next int or next double, but it's typically will just put you in a bad state because then you have an extra enter key somewhere and it gets confusing. Mr. Gaddis talks about it. You can read his solution in the text, but it's annoying. We can get a bunch of integer values, right? And like, hey, here's someone's name, and we're asking them to do something. Right? So I think you've got everything you're going to need in here. Just figure out those last little bits of arithmetic. Look at that, you can even like modulus stuff to get a remainder after you divide things out. Imagine that. What else do you guys think? Do you need more coffee? Is that the problem? I know these 10 a.m. classes, they're early. Early. We had a group of new faculty members who all started this fall. There's 7 of us, 9 of us, I forget. I'm bad at counting. And they had gotten us connected with some more experienced faculty members to do like this mentorship kind of thing. And one of them, bless her, she's an English teacher. And she said, oh, why don't we get together Friday mornings? We can get coffee and chat. And she said, okay, how about Fridays at 8 a.m.? And I replied back and I said, I'm going to be honest here. I got into computers specifically so I didn't have to be awake at 8 a.m. on a Friday. Yes, yeah, horizontal boards going between the posts. So given some posts, we're putting the boards up. So imagine your little, your grass here, right? Here's your yard. You put a big post in here, put a big post in here, and we're going to run a board this direction. So there's the post, there's a post, here's the board. Not the prettiest fence in the world, but it'll do. That's actually a halfway decent drawing. Not great, but halfway decent. 2 posts per side. I mean, so like whatever the length is and the distance between posts. So if I say this is a 12-foot length, right? Then I have a post here at 0, a post at 3, a post at 6, a post at 9. I'll have one more post at 12 feet. They should probably all be the same height, right? 12 feet. So that there is the 12-foot length. Yep. Yeah, so posts every X feet. Yep. So that's the first question, right? Is how far apart are your posts? We're assuming our contractor friend knows how to figure out how many posts he needs to buy. That's not hard math. I mean, none of this is hard math, but that's okay. And we're just going to run the boards between the posts. This might be enough to keep horses in. I don't know. I could take a picture of the horse farm next to us and show you, but I think they use more than one board. So maybe it's a bad example, but that's okay. It would just multiply. Okay. Oh, I got a new joke for you guys too. You'll like this one. You will like this one. Maybe. You know, when I say you'll like it, I'm assuming you like dad jokes. So there was a recent survey of people. And, you know, people, they love to have all these surveys out. And now that we're done with political season, we can do these just stupid surveys for nonsense stuff. And they said 9 out of 10 people who are afraid of hurdles never get over it. Or how about this one? You know, you always get these, like, the great advice from your grandmother. Well, my grandmother would always say, never put all your eggs in one basket. Going shopping with her was terrible. You know, having all these different baskets everywhere. All right, that was a bit of a stretch. All right, anything else? Are we good for now? Thanks, I hate it. Hydration, yeah, you got it. You got it. Hydration. All right, I'm just killing time here. I think we're good. We covered all the topics. I'm happy to chat more about anything if you have other questions. If not, I think you guys have everything you need to get started on the first project here. Again, make sure, a couple other tips. This is good. This is worth doing again. When you start your project in NetBeans, you go to new project, Java application, make sure you put it in your GitHub repository folder. So mine, right, CIS 1500, or you can use Browse, right? Browse is pretty good at this too. So in GitHub, CIS 1500, winter 2021. Then you give it the project name, right? So like project 1, you hit finish, and in your GitHub desktop client, you're going to see a bunch of stuff. 5. Winter, here we go. So I'm going to uncheck some of these for just a second because I want to be able to add these in for you here. Okay. Don't worry about having to uncheck stuff. You probably won't ever need to, but I'm going to save in all my changes here. Oh, I formatted. That's why I think those lines are funny. So this is more chapter 2 examples. Strings. So I'm going to commit and push. Once you start a project, there we go. Now I see them all. You should get a bunch of files. Right? These are all the project-related files and your Java file. That's the good one, right? I want all the project files because that makes it easy for me to open. If all you give me is the Java file, I have to go copy-paste, and I have to make sure my project name matches, and I have to go create a file of the same name, because despite me saying call it project 1, not everyone uses project1.java, so I can't just, because remember the class name has to match your file name exactly. Some people use lowercase, some people use spaces, and it gets really confusing. So just put it all in there for me. It'll make life easy for me. Just leave it all checked, you commit, and commit as many times as you want. Great, not a problem at all. So this is project 1 started. I'm going to hit commit and push. Then you go to repository, view on GitHub. If you can see it on github.com, I'll be able to see it on github.com. So, and that's what you're going to give me is the URL to your file. So go look for it on github.com, navigate into your folder, into the source folder. Here, so I'm going to find project, oops, it's not there yet, so refresh. I just didn't wait long enough. I wasn't patient. Come on. Nope. Oh, I forgot to push. So if you don't see it, come back here. I did that on purpose. Make sure you push and let it sit and spin and think about it for a minute. Because if you have a commit locally, but you haven't pushed it, github.com has no idea. There we go. Now refresh. And we get project 1. There we go. So I'm going to come into project 1, open it up. And I'm going to open up the source folder, project1.java. Here is the URL. Copy that whole URL. Give me that in Desire to Learn. And I can find it and grade it. And life is good. Again, you want to make things easy for the person grading your assignment, right? Don't make me go looking for stuff. I'm still going to grade according to the rubric, but I'll be irritated. And just let's just be kind to me. I've got a lot of you guys to grade. All right. What else? Any other questions, thoughts, concerns? Ready to move on? Are you guys actually reading the book? Does anyone open this thing? It's actually a decent book. I mean, and you paid a bunch for it, which is I feel bad about. And I have a personal mission to find cheaper books, but that's just me. I have to work on convincing everyone else. Okay, good. I mean, I don't expect anyone to like read every single word in there, but something more than skimming, right? I mean, I remember being a student where like you flip through, you find the bold words, you read the stuff around the bold words, you call it good. You got to do a little bit more than that, and like look at some of his examples, but it's not like you have to open it up and study it and read the chapter 3 different times, front to back, every single word, type out everything he has in there, right? Find some happy middle ground. But he's definitely, Mr. Gaddis is a good reference, a good source there. I'm trying to show you one set of examples. He's going to show you another set of examples, and you're going to practice it. Because you got to read it a couple times, you got to try it a couple times before you start to feel comfortable with it. So it's going to take some practice. So get to writing some code. If you can plan out your steps with this pseudo code idea, like, and just sketch out what your algorithm is, right? That's just, the algorithm is do this, do this, do this, do this, do this, do this. If you can sketch that out, you'll be in much better shape, because you can then check that before you even write any code. Say, okay, well, if I know what the length is, and I'm going to calculate how many boards I need for the length, and then I'll multiply that by 2, you might think in your head, oh, wait, I'm going to screw that up if I have leftover board, because for a 15-foot fence, if I have 3-foot sections, I need 5 pieces. But if I get 6 pieces, I need to make sure I'm using this other piece. Does that make sense what I'm trying to say there? Right, so I can't just calculate for a single length and then double it. I need to calculate for the entire perimeter to get the right number of actual pieces that I cut out of my boards. Otherwise, you're going to overshoot the value. I mean, sure, if you want posts every 8 feet and you buy 8 feet boards, you'll get 1 board per set of posts. That's easy. But if we have anything like I want less sections here, and again, it's all based on whatever the user types in. I could say I want posts every 2 feet and I'm going to buy a 100-foot board. It doesn't have to be real life. We're just taking the values they give us and running with it. Okay? I don't know where you'd buy a 100-foot board, but we're going to pretend you could if you wanted. So maybe all I need to do is buy 1 board to do my entire fence. Sure. Why not? Maybe I want a 2-foot by 2-foot fence. Right? I want a little place to put my toddler so he can't run away in the backyard. Sure, a little 2x2 area, little pen for him. I'm going to build. Sure, 1 8-foot board will do the trick. Right? So go through the steps here, this pseudocode idea, and you can verify, we'll call this your model of your code. You can verify it. We can try it. I'll show you more of that, and we're going to do some more pictures. Like actually sketching stuff out is really nice and useful. We'll do more of that next chapter. So this is not due until, oh, right here, February 8th. So we do have time. Where's my calendar? There's my calendar. So that is a week and a half. So we have lots of time to get this done, right? But don't wait until February 6th on the weekend to start it. I do my best to try and get back to you guys if you have questions, comments, concerns, emails, messages, whatever over the weekend. But I don't have any dedicated time, and occasionally I do family things, and I just will not answer you. Within 24 hours I'll get back to you, but if you wait until the day before it's due or the weekend before it's due and you have all sorts of questions for me, it might not go well for you. Can we say that's a fair expectation? Okay, but if you're starting earlier and you have questions throughout the week, that's much easier to help you, right? Because I've got dedicated office hours Monday, Tuesday, Wednesday, and Thursday to hang out and answer questions. I'm around a lot of Fridays. I don't know, I try and do family stuff on Fridays if I can help it. Okay, so don't see the due date and assume you don't have to do anything and wait till the very end. Get it done early, right? Then you feel good. Right, other thoughts, questions, concerns? Don't forget we do have study group today at noon over in Zoom. You guys can get to know each other a little bit, hang out there. Oh, good, I got to get more of those graded today. Sorry. I'll get the rest of those graded for Project Zero. Study group today, if you do attend, I'm going to post the Chapter 2 quiz shortly. You'll be able to get a bonus point on the quiz. So that's your incentive to go and spend some time studying this a little bit more. Okay? I think that's all I got. Finishers, no red lines, can't compile. It should give you a message about why it's not compiling. It usually will say something in there. That's not... Here, let me go back to this one here. Something like that. I mean, usually it redlines it too, but... So maybe you're just missing it, but if you try and compile it, it should tell you about what line number it's upset with. So right here. It didn't give me... so I had to scroll over here. So here, line 140 is where it thinks there's a problem. So sometimes you have to scroll over to see that message. But that's that little colon number. That's a line number. Yeah, and if you get stuck on something like that, I'm happy to help. It's a quick screen share. I can spot most of those pretty quick. Or if you commit it to GitHub, as is, and shoot me a message and say, hey, it's not working, I can go take a look. That's even easier. So I can check on stuff on GitHub pretty easily. Okay? All right, gang. Why don't we call it a day then, if you don't have any other questions. I'll hang out on Discord for a while if you have other questions you want to ask. If not, you can drop by my office hours. I'll be around today 1 to 3. You guys can go get some food. Get some more coffee. It just runs with what's your name. Yeah, it should ask what's your name, and then it should wait for you to enter something, because we're asking them to enter their name. That should be the first thing it does. Nick. Oh, Dusty. I appreciate that. All right. You guys take care. See you around.